last lecture, we learned a few concepts about double integral. Uh, the first one was when region of integration is rectangular, and the other one was when region of integration is non-rectangular. Okay. So now I will write a theorem. Its proof is not in our scope, but this theorem will help us to know the circumstances under which the order of the integration is if it is changed, then the integration value will remain same. So it is called Fubini theorem. Fubini theorem. What it says, let fxy be continuous. Let fxy be continuous on a region R, in a plane, then double integral over the region R fxy dA. This will be equal to double integral of fxy dy dx, where y equals to f1x to y equals to f2x and x equals to a to x equals to b, and the same integral will be equal if we reverse the order of the integration. Fxy dx dy and x equals to h1y to x equals to h2y and y equals to c to y equals to d. So if fxy is continuous on that region where we are executing this double integral, then either if you evaluate dy dx or you evaluate dx dy, the values are going to be the same. All right. So that was the thing which we wanted to discuss here. Means this theorem will give the idea when these repeated integrals will be the same. Okay. I advise you to look for a counter example. I means try to figure out a example where discontinuous function is there, and if you take one order, the integral value is different, and for the another order, the integral value is totally different. Okay. So that was the thing we wanted to see here. Now I'll take an example which will help us to figure out the this geometrical one of the geometrical meaning of double integral when integrand is fxy. So in the last lecture I already told you, if there is an integrand inside fxy, then that double integral actually gives us the volume of that particular region. Okay, so we can write a formula in double integral as well. Volume. Okay, the volume enclosed by the surface z equals to fxy over the region R is, I think yesterday we already understood it, how it is. So this will be double integral over the region R fxy dA. And for dA you can choose any particular order. So I'll take an example, then we'll move ahead. Find the find the volume find the volume of the solid. Find the volume of the solid that lies beneath the surface. Beneath means under the surface. Beneath the surface z equals to 16 minus x square minus y square. Okay. And above the region R, bounded by the curve y equals to 2 root x and the line y equals to 4x minus 2, y equals to 4x minus 2 and x-axis. Okay, so just now we have figured out the volume, the formula for the volume, and that formula is double integration over the region R fxy dA. And what is R here? Let us try to draw the region R. This stands x-axis and this is y-axis. So y equals to 2 under root x, means it's a parabola like this. And then y equals to 4x minus 2. This is y equals to 2 root x. Okay. And then we have a straight line which is y equals to 4x minus 2, and suppose it goes like this. Okay, so it will go like this, and we can remove this part. Okay, and the x-axis, what is x-axis? X-axis means this portion. So this is the region of integration. This is the line y equals to 4x minus 2 and x-axis, and above this region we have a surface z equals to 16 minus x square minus y square. Okay, so we can evaluate this volume easily. In place of fxy, simply write 16 minus x square minus y square. Suppose we are choosing the order dx dy. Okay, dx dy. All right. So how we can put the limit? Again, draw an arrow parallel to x-axis like this, and then try to figure out what is the entering boundary and what is the exiting boundary. This is under root x. Okay. So y is x equals to y square by 2, y square by 4, sorry, because we have y equals to 2 root x. So if I try to write in form of x, so x will be equals to y square by 4. So x equals to y square by 4 to x equals to y plus 2 by 4. Y plus 2 by 4 means this line. Okay. And the coordinates of this point, if you try to figure out, this is 1 comma 2. Okay. So y is starting from y equals to 0, means this x-axis, and its uppermost point is 2. So y equals to 2. You evaluate this integral, it will lead you to the result. So I'm not evaluating the integral because you can do it. It's not a problem. It's just uh, a simple calculation. Okay. So this was one of the, but suppose if I choose the order dy dx, then what would happen? Because this fxy is continuous. So over this region, and this continuity we can observe it. We don't need to prove it because it's a polynomial kind of a structure, and polynomials are everywhere continuous. So we can evaluate the same volume by changing the order as well. So instead of this, suppose if I choose this particular order, double integral 16 minus x square minus y square. Suppose I'm choosing dy dx. Okay. So if I'm choosing dy by dx, then what would happen? Again, what I need to do, I need to draw a line which is parallel to y-axis like this, and then I need to take the limit for first y, then followed by x. But if you carefully observe, the lower bound of, in this particular case, if I choose the order dy dx, then y bound is not governed by a single curve. It is actually a composition of or collection of two curves. Up to this point, the lower bound is y equals to 0, but after this, the lower bound is this line. So what we need to do, we need to divide this whole region into two parts. Suppose this region is R1 and this region is R2. So what I need to do, I need to write the double integral first for the region R1, 16 minus x square minus y square dy dx plus double integral over the region R2, which is again 16 minus x square minus y square dy dx. And now I'm leaving you as an exercise to put the limits of first integral if it is over the region R1, and the limits of second integral if it is over the region R2. But once you solve these both integrals by putting the limits for y and x, it is going to come out to be the same value. So with this example, so I'm not solving it, even I'm not putting the limits. Those who have understood, they can easily figure out because I explained it many times. So the purpose of this example was why I discussed both the orders dx dy and dy dx. So if you go for the order dx dy, then you need to do less amount of computation, because in that case we do not need to divide the whole region into two parts. But in the later case, when the order is dy dx, we cannot write this integral as a single double integral. So it is required to distribute the region into two parts so that we can put the required limits. So it is our choice. We are free to choose any one of them, but it's our smartness and it's our wise full decision that which order we should choose. So in this particular example, we should go for the first choice, that is the order dx dy, because that requires the less amount of computation. Okay. So this is the way we should understand. So I'm not completing this example numerically. You just carry on and do it its final computation. Okay. So that was the thing. And area I already explained you. Now we'll try to do the same thing into the polar coordinates. Okay. Okay. So double integral in polar coordinates. Integral in polar coordinates. Okay. So before I go with the double integral, we'll try to understand few basics of polar coordinates, and we'll try to learn how can we draw certain curves if they are given in the polar coordinates. Okay, because whenever you are solving a double integral, in every case you need to plot the region of integration, means what is the region enclosed where you need to choose the limits for x and y. uh, Same thing is in polar coordinates. Polar coordinates again, we need, when we need to choose the limits, we need to draw the curves. So first we'll understand how this polar coordinate can be represented and in an equivalent way, how we do the same thing in Cartesian coordinate system. Then we'll understand few basics of polar coordinates, and then we'll do some examples by which we will learn the fundamental plotting concepts. Okay. So unlike in Cartesian coordinate system, we have this x-axis and y-axis. This is x-axis and this is y-axis. On the other hand, in polar coordinate system, we do not have uh, axis. What we have a simple pole, which is an equivalent of origin in the Cartesian coordinate system, and then we have an initial line like this. Okay, and this line we represent by the angle theta equals to 0. Okay, and how can we convert any Cartesian coordinate system into the polar coordinate system? We are going to use this substitution: x equals to r cos theta and y equals to r sin theta. Okay, so you already know how to represent a point in Cartesian coordinate system. For example, suppose this is the point whose coordinates are a comma b. So it's pretty clear. A unit on the x-axis and b unit on the y-axis. But there is a slight difference in the point representation in the polar coordinate system. For example, if the suppose same point I wanted to represent in polar coordinate system, then how can we do that? Suppose this is the same point and I wanted to represent it in terms of polar coordinates. So how we are going to do that? We are going to measure its distance, direct distance, in a form of a vector from the pole. Okay, so suppose this distance is r. Okay, so what we'll do, first component of our point representation would be r, and then measure how much angle it is creating from the initial line or the line theta equals to 0. Okay, so if this angle is theta, so r comma theta. So in this way, we are required to understand and represent any point. So this is kind of an equivalent of a comma b in Cartesian coordinate system. And whenever we wanted to convert this AB into polar system, we are required to use this substitution: x equals to r cos theta and y equals to r sin theta. All right. On the other hand, in the Cartesian coordinate system, we have four quadrants. In the first quadrants, all of them are positive. In the second and fourth, one is positive, one is negative, and in the third quadrant, all of the entries are negative. But here, in the polar coordinate system, we have a privilege not to choose the value of r as a negative value. Means we can always have the r value as a positive value, and still we would be able to express and represent each and every point which are available in the entire plane. Okay. For example, suppose I wanted to express what is minus r comma theta. Okay, minus r comma theta. So if I follow the properties of vector, so what would happen? Suppose if this is the r vector, then what would be the minus r? Minus r is going to be this particular vector. Okay, so this point would be how much? Minus r comma theta. But we can have a different representation of this minus r comma theta by simply writing r comma theta plus pi, because what is happening, to locate this point from the initial line as a frame of reference, what we need to measure, we need to measure this entire angle. Okay, so this entire angle is how much? Simply pi plus theta. So whenever r is negative, just simply add pi to the other component, that is theta, and it will represent the same point. So this is the richness of polar coordinate system, where with a negative of r, we can always treat it as a positive by simply making this modification to the angle theta. Okay, and these are the particular lines. If I compare it with the Cartesian coordinate system, so this line is theta equal to 0. This line is theta equals to pi by 2. This line is theta equals to pi by 4. This line is theta equals to 3 pi by 4. This is theta equals to pi. And in this way, this is theta equals to 3 pi by 2. So these are the lines, equation of the lines, which we have expressed on polar coordinate system. Okay, so these are the few fundamental things of polar coordinate system. Now I'll take an example which we will draw, and that will help us to learn how can we draw some curves in polar coordinates. Okay, so we are going to use the very fundamental idea, the way you have drawn the curves in your early classes, where how you do this. Suppose y equals to fx is given to you, then what you did, you were writing few functional values of function at different points, x equals to say 1 2 3 4 5, and then you evaluate its functional value, the value of function at these points, and then you identify those points on the Cartesian coordinate system, then you try to match them with a dotted line, and it actually leads us to the structure of the original curve. So the same idea I'll use here while drawing the curve. Okay, so we'll do a few examples so that you would be totally comfortable and familiar with the drawing of polar curves. Okay, suppose if I take this example, in general, the way we have the function y equals to fx. Okay, in polar, the same we represent by r equals to f of theta. Okay, so suppose we have a function r equals to 1. Okay, let me take this example later. First, let me go with r equals to cos theta. R equals to cos theta. So I'll draw a table where we will be having the values of r at different values of theta, and that will lead us to the original structure of r equals to cos theta. Okay, so Suppose I'm writing theta at certain values, r. Okay, so let's start with theta equals to 0, theta equals to pi by 2, theta equals to pi, theta equals to 3 pi by 2, theta equals to 2 pi. That would be enough for this example. So at when theta is 0, r is 1. When theta is pi by 2, r is 0. When theta is pi, r is minus 1. When theta is 3 pi by 2, r is again 0. And when theta is 2 pi, it is again 1. Okay, so let us try to catch how we can draw this curve using this particular table. So this is going to be our initial line and this point will be the pole. So this line is nothing but theta equal to 0 as well. So at theta equal to 0, the value of r is 1. So suppose this is the 1 unit from the pole. Okay, so at theta equal to 0, the rider of r is locating or pointing this particular point. Okay, and now as we move towards the theta equals to line, the line theta equals to pi by 2. What is happening? This 1 is decreasing from 1 to, the value of r is decreasing from 1 to 0. And since sine and cos, they have a cyclic nature, so it will not decrease linearly. It will decrease in a form of an arc. Okay, so suppose at theta equals to 0, it is 1, and at theta equals to pi by 2, it becomes 0. Okay, it goes like this and it ends at theta equals to pi by 2, the value of r is 0. Okay, and then what is happening when you are moving from pi by 2 to pi? What is happening? Now the value of r is going to be negative. Okay, the value of r is going to be negative. It means what? It is decreasing from 0 to minus 1. Okay, so I already told you, when r becomes negative, so then minus r comma theta, it can always be understood like r comma pi plus theta. Okay, so what will happen? Suppose if it would have been the case, it is increasing from 0 to 1. So how this curve should have been gone further? It should have been gone like this, in this way. Okay, at pi by 2 0 and at pi 1, I'm just assuming it is not negative. But since it is negative, so what will happen? Each and every point which is marked as a pink point here, what it will do, it will take a rotation of pi degree. Okay, so just rotate this entire curve pi degree and what you will get? You will get this kind of a structure. Instead of this, this line will be theta equals to 3 pi by 2. 3 pi by 2. So instead of drawing this here, it will draw a curve here. Let me remake. It will start like this and it will go like this. Okay, actually the loop will be the same length. Okay, like here. And then further what is happening? When it is moving from pi to, so when theta moved between pi by 2 to pi, the r is moving like this. Okay, and when theta moved from pi to 3 pi by 2, again what is happening? It is decreasing from -1 to 0. So again the same thing. If it would have been a positive number, so it would have been gone like this. Pi by 2 to pi, pi by 2 to pi, it should have been gone like this. But what will happen? It will take again a shift of pi degree. Okay, and when it will take a shift of pi degree, instead of creating this structure here, in originality it will create a loop here like this. So this pink dotted lines are those I have just drawn it to get to know that where exactly it will trace the curve. Okay, so here and so far we have reached up to the point theta equals to 3 pi by 2. So again, if you are moving theta equals to 3 pi by 2 to 2 pi, what is happening? It is moving from 0 to 1. So what will happen? It will increase at this point and it will go like this, because now it is in a positive, so it will go like this. Okay, so in this way you will get this kind of structure. Okay, and then when it will be 2 pi by 2, it will be this. I have missed something here. Theta equal to 0, it is 1, pi by 2 it is 0, pi it is -1, this is fine, and 3 pi by 2 it is 0, 2 pi it is 1, this is also fine. And suppose if I further move 2 pi plus pi by 2, 5 pi by 2, so then it will repeat 1 to 0. Okay, let me just check it. Hmm. Oh, actually, I think I made some mistake. Let me draw it again from the scratch. It should come out to be a circle. Okay, this is initial line. When theta equal to 0, r is 1, theta equal to pi by 2, it is 0. So it will go like this. fine. And when theta equals to pi by 2 to pi, okay, that was the mistake I made. All right, this is theta equal to 0. This is theta equal to pi by 2, and this line is theta equals to 3 pi by 2, and sorry, theta equals to pi, and this line is theta equals to 3 pi by 2. Okay, so yeah, fine. That was the mistake I just committed. So basically what would happen when theta is moving from pi by 2 to pi? So 0 is this point, and suppose if it is positive, so what will happen? It should go like this. Okay, it's replication. But since it is negative, so what would happen? It will transfer everything 180 degree. So in originality, it will draw the original structure here. Okay, and again if you see from 3 pi by 2 to 2 pi, here to here, sorry, pi to 3 pi by 2, what will happen? It is again -1 to 0. So -1 to 0, if it suppose if it is positive, so it will start from here and it should go like this. But again, since it's all in negative, so what will happen? It will repeat the first what I have drawn in the first quadrant. And in this way, if you keep on doing, it will keep on repeating this entire thing on the in the fourth and the first quadrant. So the original structure would be like this. This will be your r equals to cos theta. Basically, it's a circle. I have drawn it in a form of a loop, but it's a circle which you can see easily. It is r equals to cos theta. So I can convert into the Cartesian coordinate where you are more familiar. If I multiply both sides with r, so r square equals to r cos theta. So r square is x square plus y square, and r cos theta is x. So if I take out take x this side, so this is nothing but x minus 1 by 2 whole square plus y square equals to 1 by 4. So this is nothing but this circle. Okay, but this is the way we have to draw any particular curve. All right. Let me take one more example. Uh, I'm giving you an exercise. Try for r equals to cos 2 theta and r equals to sin 2 theta. Okay, so I'll do another example, which is r equals to 1 plus cos theta. Okay, r equals to 1 plus cos theta. So again, let me create a table so that it helps us to know where the values are moving. Okay, so this is theta, this is r. So theta equal to 0, r is 2, theta equals to pi by 2. R is 1 and theta equals to 3 pi by 2, not 3 pi by 2, pi. R is 0 and theta equals to 3 pi by 2. Again it will be 1, and when theta equals to 2 pi, again it is 2. Okay, so we can take a similar way to draw it. So again it's the initial line with the pole origin, and this line is theta equal to 0. So at theta equal to 0, r is 2. Suppose this distance is 2. It is starting from here, and at theta equals to pi by 2, this line is theta equals to pi by 2. This line is theta equals to pi by 2. So it is starting at 2 distance, and at theta equals to pi by 2, it is moving like this, and this length is 1. Okay, and when theta equals to pi, then again it is decreasing from 1 to 0. So it will go like this. Okay, and when theta equals to pi to 3 pi by 2, so this line is theta equals to pi. Okay, and this line is theta equals to 3 pi by 2. 3 pi by 2. So when theta moves from pi to 3 pi by 2, again it starts from 0 and goes to 1. Okay, and at from 3 pi by 2 pi, it is increasing from 1 to 2. So it will go like this. Like this. Okay, so it's a class of curve. It looks somehow the shape of heart, and we call it cardioid. Okay, so this is the way we plotted this particular curve. Okay, but if you try to convert it into the Cartesian coordinate system, you can do it, but it is really going to be very challenging to plot it into the Cartesian coordinate system. Now I'll take your queries. Ayush?
Yes, sir. सर डाउट तो हो गया सर, क्लियर हो गया.
ओके, हो गया. आदित्य?
सर ये कार्टेशियन कोऑर्डिनेट में प्लॉट कैसे करते हैं सर, यही नहीं समझ में आया सर.
किसको कार्टेशियन में प्लॉट करते हैं?
नहीं मतलब सर ये पोलर कोऑर्डिनेट्स में सर ये कैसे प्लॉट किया ग्राफ सर, ये समझ में नहीं आया.
यही तो मैंने 2 एग्जांपल लेके एक्सप्लेन किया आपको. ये वीडियो आप दोबारा से देखना, नहीं आएगा तो मुझे बताना. ठीक है. आनंद?
सॉरी सर, क्लियर हो गया था, गलती से रेज हो गया था.
तो आप लोअर हैंड कर लीजिए. ईशा?
Sir, kindly will you show slide 96?
96?
Yes, sir.
बताइए.
Sir, I didn't understand the computation of which integral was easier and why. Because computations in both the cases it will be a bit complicated. I didn't understand.
No. I'm not saying calculation would be difficult or easy. Because if you choose the order dx dy, then to solve this integral, you do not need to divide the entire region into 2 parts. But while if you choose the order dy dx, then you need to set up 2 different integrals by dividing the region. So it actually increases our work, because now you have 2 double integrals whose limits you need to put. That is the only difference. It's totally our choice which order we want to follow. If you find that the second one is easier, it's totally your choice.
So why is the second integral divided into 2 halves, 2 parts?
Because if you try to see suppose if I try to choose the limits of y, so the lower bound of y is actually a collection of 2 functions. If I move from here to here, the lower bound of y is governed by this portion of x-axis, that is y equals to 0. But as long as we moved after this point, this x equals to 0 is no more a boundary for our region. after this the boundary is this line y equals to 4x minus 2. So we don't have a common curve or a single curve which uniformly or universally describes the lower bound for y this region. That is why we need to split into two regions. Okay.
Sorry, sir, but I didn't understand this.
What you didn't understand? First let me know, then I can explain.
Lower bound in the sense. So actually, the very last thing.
What I'm saying, you know how to put the double limits of a double integral when the region is non-rectangular. आपको मैंने ये कल सिखाया था. Let me actually this is I'm repeating. ये इस तरीके से मैंने आपको सिखाया था ना कि जो भी टोटल रीजन है, you try to imagine many arrows and then try to figure out what is the lower bound of, means what is the curve from which these arrows are entering in this region and what is the curve from which these arrows are coming out of this region. Okay, so the curve which is entering curve, that would be the lower limit, and the curve which would be exiting curve, that would be the exiting limit. Okay, but in our case, in this particular example, if you try to draw similar multiple arrows, so what will happen? आप अगर ऐसे ढेर सारे एरो ड्रॉ करते हैं तो जो रीजन ऑफ इंटीग्रेशन है, रीजन ऑफ इंटीग्रेशन तो आपका ये है, दिस एंड दिस एंड दिस. सो फॉर ऑल दीज एरोज द एंटरिंग कर्व इज नॉट सेम. Up to this point, the entering curve is the line y equals to 0. And after this, the entering curve is line y equals to 4x minus 2. So which one I should choose?
Sir, but the graph y equals to 4x minus 2 is not extended downwards.
No, you are totally not getting what I am explaining. मैं अलग से ये पिक्चर बनाता हूँ. रीजन जो हमारा है वो ऐसा है, ये इस तरीके से ऐसा है रीजन. ओके, अब यहां पे अगर आप ढेर सारे एरो ड्रॉ करते हो, सॉरी, अब अगर यहां पे आप ढेर सारे एरो ड्रॉ करते हो, आपका जो इन सारे एरोस का जो एंटरिंग बाउंड्री है इस रीजन में वो अलग अलग नहीं है. आर यू नॉट एबल टू ऑब्जर्व इट? यहां से यहां तक तो ये पोर्शन ऑफ एक्स एक्सिस है, ठीक है, और
Okay,
इसके
so
आगे
so
ये
the negative.
नेगेटिव व्हाट?
So that means you didn't consider the negative values of y. You didn't consider that part of the graph which contains negative values of y.
That is what R says, bounded by the curve. आप क्वेश्चन देखो ना, bounded by the curve y equals to 2 root x and the line y equals to 4x minus 2 and x axis. इन तीनों कर्व से बाउंडेड जो रीजन है, तो y will go to the negative y.
Oh yes, sir, I got it.
Okay.
Sir, one more doubt, sir, on slide 98. So on slide 98, I understood the nature of graph with the help of the computation, but I didn't understand how you took out the graph with the help of logic, like you were drawing it.
Which logic?
I understood this thing that r equals to cos theta, r square equals to r cos theta, how you calculated this and how then you interpreted the graph. But then you were saying that theta equals to 0 and then you were drawing it without calculation. So how that thing I didn't understand.
No, I calculate because we are, I already told you, we are dealing with the transcendental functions, basically cos. So whenever the architecture of cos or sine would be, it is going to be some circular structure. अगर आप sin x cos x का भी function का ग्राफ देखो तो it is recursive kind of thing. Okay, हम यहाँ पे क्या कर रहे हैं कि we are evaluating the value of r equals to cos theta, means this is treated as r equals to f of theta. Okay, so this value is nothing but f of theta. Okay, and then we are choosing different values of theta on our own and we are evaluating the value of corresponding r. And the way we do the same thing in the Cartesian coordinate system, the way you learn plotting in your early classes, same thing I am doing. The only thing what I am doing new here, how you know that between theta equal to 0 to theta equal to pi by 2, this will go like this. This is idea we are getting, that since we are dealing the cos function, so it will not go linearly, it will go circularly. This is what instinct we are following. Okay.
So, but at theta equals to 0, r will be 1. So why did you
Yeah,
plot
r
it
is 1.
on the axis?
When theta is 0, r is 1. You misunderstood what is r. R is this radius vector. We call it radius vector. So when theta equals to 0, this value is 1. This is what I have written in the table, and this is what this plot shows. Okay.
Okay, yes, sir, I got it. Yes, sir, thank you, sir.
Sumit.
सर स्लाइड नंबर 97 पर जाना।
हाँ बताइए।
सर यहाँ पर हम थीटा की डायरेक्शन आर से एक्स एक्सिस ले रहे हैं, तो फिर यहाँ पर सर थीटा प्लस पाई की जगह सर पाई माइनस थीटा होना चाहिए।
आर की कैलकुलेशन कहाँ से ले रहे हैं
सर? डायरेक्शन आर की सर, ओ फाई की थीटा की सर डायरेक्शन।
नहीं, ये दिस इज रॉन्ग। ये डायरेक्शन हमेशा काउंटर क्लॉकवाइज है। ठीक है,
ठीक है।
मतलब हम जो मेजर करेंगे वो ऐसा करेंगे, इधर नहीं मेजर करेंगे। ठीक है, जैसे आपने सीखा है, दिस इज नथिंग न्यू। गर्व
सर
बताइए।
सर एक बार स्लाइड 96 ओपन करना।
बताइए
सर इसमें जब हमने उसको R1 और R2 में डिवाइड कर लिया था, तो उसके बाद हम कैसे उसके लिमिट्स क्या लगाएंगे इंटीग्रल में?
आप R1 की लिमिट्स अलग से लगाओ, R2 की लिमिट्स अलग से लगाओ।
नहीं सर, वो
R1
लिमिट्स
की आप
लगेंगी, मैं वो पूछना चाह रहा था।
You want me to write it? Okay. R1 की लिमिट हो जाएगी आपकी y इक्वल्स टू 0 टू y इक्वल्स टू 4x माइनस 2। ओके, और इस पॉइंट का आपको वो निकालना पड़ेगा कोऑर्डिनेट, और इस पॉइंट का कोऑर्डिनेट होगा व्हेन
हाफ
y
कॉमा रूट 2, हाफ कॉमा रूट 2।
नहीं, यहाँ पे इस पॉइंट पे व्हेन y x इक्वल्स टू 1/2, ये 1/2 होगा। ठीक है, तो x will be 0 to x equals to 1/2। ये R1 के लिए हो गया, और R2 के लिए आप जब लिखोगे, R2 के लिए ये स्टार्ट होगा y equals to 4x minus 2। नहीं, ये गलत लिखा है मैंने, ये y equal to 0 to y equals to √2 x। नहीं, y equals to 4x minus 2 to y equals to 2 √x, and x will be 1/2 to x equals to 1। ये लिमिट्स हो जाएंगी।
ओके सर, यस सर।
आपको जो सिखाया है मैंने, हाउ टू चूज लिमिट्स, आप उस पर फोकस करो। इस रीजन को ड्रॉ कर लो, द वे आई हैव एक्सप्लेन्ड उसी तरीके से आप लिमिट रखो। ठीक है,
यस सर।
यस चेरी।
सर
बताइए,
वो आप ग्राफ समझा दीजिए प्लीज।
कौन सा ग्राफ?
r इक्वल टू 1 प्लस कॉस थीटा वाला।
r इक्वल्स टू 1 प्लस कॉस थीटा में हमने क्या किया कि इस r की थीटा की डिफरेंट वैल्यूज पे r की वैल्यूज को इवेल्युएट कर लिया, और हर एक थीटा इक्वल टू 0 के लिए इसको हमने प्लॉट करते चले गए। तो व्हेन थीटा इक्वल टू 0 r is 2, and when theta equal to pi/2 r is 1, it means r is decreasing from 2 to 1 circularly, so it moved like 2 to 1। and when
ओके सर, गॉट इट। यस सर, गॉट इट।
pi/2 से pi जा रहा है, तो आप ऐसे देख सकते हो। ठीक है,
ओके सर, थैंक यू सर।
ओके ठीक है। You just check your textbook and try to practice few more examples. I already gave you r equals to cos 2 theta and r equals to sin 2 theta. ऐसे ही और भी एग्जाम्पल आप ट्राई कीजिए. Tomorrow we will learn how to evaluate the area using polar coordinates. Okay. Suppose इसी रीजन के अंदर हमें एरिया निकालना है कार्डियाइड के, तो वो एरिया कितना होगा, हाउ कैन वी इवेलुएट, दैट विल सी नॉट टुमारो इन द नेक्स्ट लेक्चर. ओके. रिंकू क्या कह रहे हो आप, बोलिए.
सर जो पेज नंबर 97 पे जो हमने वो वॉल्यूम वाला फॉर्मूला लिखा था वो पुराना वाला ही फॉर्मूला है ना?
हाँ पुराना ही फॉर्मूला है. आई जस्ट रिपीटेड इट.
ओके सर.
How to find Cartesian equation of 1 plus cos theta? You just need to convert it into x and y using x equals to r cos theta and y equals to r sin theta. It may not look like very good. That is why we are learning it into polar coordinates. ये देखो किसी बच्चे ने किया भी है. ओके. अब इसका अगर मैं आपको प्लॉट करने को कहूँ तो then you will leave my lecture. Okay. अगर instead of r equals to 1 plus cos theta, if I would have said x power 4 plus y plus 4 and so on, whatever it has been explained, so you would have changed your mind to learn mathematics. That is why that is the motive of this polar coordinates, to make the things easy, which are actually pretty much weird in Cartesian coordinate system. Okay. If there is no more questions, then I shall be stopping.